Welcome, AP Chem students. Wanted to do a quick tutorial with you. Yesterday, I had assigned some bell work for Lewis structure. I wanted you to do the Lewis structure of acetylene and of ethene. And there was some misses on it. I wanted to make sure that I went back through it. I had asked to do a Lewis structure, and I asked to do a visual representation of the sigma and pi bonds, and then to talk about the hybridization. So I want to do a quick sketch of them. So first one I had was ethene, and ethene is C2H4. So when you look at that, you realize, and everyone got the actual Lewis structure of it correct, and your Lewis structure looks like that. But this is, in fact, the Lewis structure. It's not the visual representation of the sigma and the pi bonds. And that's the part that I wanted to make sure we all understood. So when I go to draw that, put my carbons, I'm going to space them out a little bit, and p orbitals are this teardrop shape coming out like this, and we have these coming out here, like that. And then I have my hydrogens here. I can place my hydrogens over here. Hydrogens have an S group, as you are well aware, and that is circular. So there's a difference in how you draw them. And that's what I wanted to make sure that we all understood. So this is sigma bonds here, but now it's a double bond. A double bond has a pi, and remember, pi occurs above and below. So here I'll draw up, and then I link them like that. So this is my representation of my sigma and my pi. So when I look and count, I have 1, 2, 3, 4, 5. So I have 5 sigma, and that's your sign for your sigma bond. And above and below is a pi. I have 1 pi. So that is ethene, the Lewis structure, the sigma pi bonds represented, and how many of each. So if I look at the central carbon hybridization, well, I can count what I got here. I have 1, 2, 3, so a steric number of 3. So that is sp2, and that's my hybridization right here. So now acetylene, let's take a look at it. So acetylene is C2H2, C2H2. So you have a triple bond, and then you have hydrogen on either side. So when I go to draw this, same process. I'm going to draw my carbon. I'm going to come out here, draw my other carbon, come over here, draw my hydrogen, come out here and draw my hydrogen. I have my teardrop shape coming out here. I have my circular here. Once again, I have this teardrop shape bond coming out, and this is a triple bond. So those are my sigmas. Now I have 2 pi on the triple. So I'm going to come up here. I have above and below, above and below. I'm going to connect them. Now I have to represent my triple bond. So I go on the z-axis, out this way, here, out this way, and here. And then I can connect them. So there I have represented now my sigma and my visual representation of sigma and the pi bond. So now I can count them. I have 1, 2, 3. So I have 3 sigma, and I have on the y-axis above and below, I have 1 pi, and on my z-axis above and below, I have a pi bond. So I have therefore 3 sigma and I have 2 pi bonds. And the hybridization, the steric number, I can count that. 1, 2. So this is sp hybridized. So this is how, and this would have been a great AP question. So please keep in mind, you very well could see something asking you. So please, if you were asked to show, you have to draw exactly as you see that I've done here. Your Lewis structure is different than your visualization of your bonding, your sigma and your pi bonds, and then you've got your hybridization. So I hope that alleviated any confusion anyone might have had as we go through these bell works that I'm going to be assigning on a daily basis. If there is errors that I see across the board, I will do a tutorial and just post it up there, short, quick, watch it, see how it is. If there's questions, if there's a tutorial you'd like me to do, please just shoot me an email and I'll make sure I post one up. Thank you for watching. Have a good day.